Hi everybody, so this is going to be number 5 from the AP, the test prep from the AP Physics 1 book. So this one says a ball is launched at an angle of 60 degrees above the horizontal. So we've got it launching like that. In the vertical position of the ball, so the height of the ball is recorded at various points in time in the table shown, assuming the ball was at a height of 0 at time equals 0. So I wrote the table here, and we also know that time equals 0, height equals 0, right? So they kind of give us our starting point. So right now we could create a position graph, right? We have everything we need to do that, but it doesn't ask us to do that. First it says, for part A, it tells us to draw a graph of the ball's velocity versus time. Okay, so sounds like we're gonna need to find some velocities. Luckily, I just happened to put this extra column in here so that we could do that. All right, so I wanna go through how to figure this out because I know some of you have had a little bit of trouble with this. So make sure to look over your work and make sure you're not making this one mistake that is very common. Okay, so we are just going to do position divided by time, right? Divided by change in time. Change in position divided by change in time. So we've got 0.49 divided by 0.1, 4.9. Okay, that one's pretty straightforward. Now this is where it gets important to pay attention. So now we're looking at our change in position over our change in time during that second time interval only, so not from the start. So in order to get this, we're going to do 0.88 minus 0.49 is 0.4. That doesn't sound right. Why did I do that wrong? 0.88 minus 0.49, 0.39. Yes, and then we are going to divide that by 0.1 again. So that gives us 3.9. Oh, I see. I did this earlier and I wasn't getting the same thing that I got. That's because I copied the table down wrong. Okay. So that one you would actually get 3.92 if you had used 0.882. Okay, now we've got 1.176 minus 0.882 divided by 0.1 to 0.94. So what I want you to notice is that I'm doing this minus this and this minus this to get this, okay? That's the really important piece here. Now I'm gonna use a little movie magic here. Okay, so this is all of our velocity, and these are all of our times. So we've got everything we need to make our graph. So then you can go ahead and draw an XY graph and plot all of these crazy points. But I don't know about you, but the idea of plotting 4.9, 3.92, 2.94 just screams out inaccuracy to me. So what I did is I went to my graphing calculator, or for me, Desmos, the website, and I did this. So I changed the X to time, which you don't have to do at all. I just did that because I like to be fancy like that. And I changed the Y to V1. And then for the Desmos software, you have to use this little tilde thing, which you know if you saw the other video that I did this in. But you would get V1, E, and I knew it was going to be a linear relationship So I did MT1 plus B. Even if I didn't know that, once I plotted these points, I saw them here. So then I knew it was a linear relationship, even if I hadn't known that before. So I knew how to give it that. And then it tells me that B is 5.88. But what I'm really looking for is this slope of this line is 9.8, negative 9.8. What? That's gravity. So that is a pretty cool thing to see. So this graph would be a great answer for this question. Okay. Another secret to part A is that you could actually just do your starting point, so 0.49 or 4.9 and 0.1, and then draw a line with slope negative 9.8, because we know that that is the acceleration in this case. And we know it's going to be linear because the acceleration is constant, and it's constant negative 9.8. All right, so let's look at B. Describe the graph of the ball's horizontal velocity. So what's happening with its horizontal velocity? Well, we don't know what its initial velocity was. We know what its initial vertical velocity was, but not its initial horizontal, which is fine because they're just asking us to describe what it would look like. And since we ignore air resistance all the time, I am guessing that, so this is V in the X direction, it would look sort of like that, right? Because that one is not the one that's changing. It's our velocity in the Y direction that's changing, according to the graph that we already made. And then the last one asks us to draw a graph of the ball's vertical acceleration versus time. Well, I've done this before, right? So this is acceleration in the Y direction over time, and we'll just call this negative 9.8, and then I will draw a straight line going across. What? I guess in order to be a good student, I would put units on all of those things that I just graphed. So that's what your graphs would look like for, what is this, number 5. I hope this helps. Thanks.